SDS PAGE. SDS PAGE is a modern type of gel electrophoresis. SDS means sodium dodecyl sulfate, while PAGE means poly-acrylamide-gel electrophoresis. SDS PAGE is mainly used to denature proteins and separate them on a gel. To understand how SDS PAGE works, let's break it down step by step. In the first step, we start with a mixture that contains various proteins in it. Then we add SDS, which stands for sodium dodecyl sulfate. It is a negatively charged detergent. It goes inside the sample mixture and breaks various bonds in proteins like hydrogen bond, hydrophobic interaction, ionic bond. However, SDS cannot break disulfide bonds. Therefore, to demolish disulfide bonds, we add another substance called beta-mercaptoethanol. Because of the existence of these bonds, proteins have a complex structure. With the aid of SDS and beta-mercaptoethanol, we break various bonds in proteins. Therefore, proteins lose their native structure, get denatured, and become linear in structure. Now these denatured proteins have a net negative charge because of SDS molecules across them. Next, these negatively charged proteins are loaded on a gel. Here the magic begins. We connect the gel to a power source and apply an electric field. When electric field is applied, proteins start floating through the gel. They march toward positively charged plate because of the negative charge on them. Remember, small-sized proteins move faster than the large-sized proteins. This way, the protein molecules get separated based on their molecular weight. Once electrophoresis completes, we use staining to see the results. So we treat the gel with a colored dye like Kumasi blue. This makes the proteins visible as bands on the gel that we can clearly see. Further, we can use blotting technique if we are interested to identify a particular type of protein on the gel.